All right, so we're going to look at 5.1 homework. And so the first thing we want to do here is we want to see, uh, we're going to look at different variables, I believe, and classify them as discrete or continuous. Okay, so we talked about this in the notes. Remember, a discrete variable takes on a countable number of values. You wouldn't have a decimal with a discrete variable like 1, 2, 3, 4. A continuous variable could have a decimal. Okay, so those are just some things to think about. The number of traffic fatalities per year in the state of Florida. So let's think about that. Is that something that's countable, like 1, 2, 3, 4, or could there be like a fraction of a fatality? What do we think? Yeah, that's discrete. It's accountable. Like you'd have 1, 2, 3, 4, 10. You wouldn't have a fraction of a fatality. You wouldn't. The distance a golf ball travels after being hit with a driver. So could that distance, that distance, could that take on a decimal or a fraction of a yard if we're talking about yards, or would it be whole yards? No, it would be continuous because it could take on, it could be 320.5 yards. Okay, so it's going to be, so the distance there is going to be continuous. Time required to drive home from college on any given day. So could that time, like if we're talking about minutes, will that be an exact, will it be like 11, 12, 13 minutes, or could it be 11 minutes and 30 seconds? Could it be a fraction of a minute? It could be a fraction of a minute, so it will be continuous. So because it could take on an infinite number of values there. The number of ships in Pearl Harbor on any day. So is that a countable number of items, or is that something where you could have a fraction of a ship? It's discrete, it's accountable. Good. Your weight before breakfast each morning. Okay, so is your weight going to be an exact pound amount, or could your weight be a fraction of a pound? Could be a fraction of a pound, so that's called continuous. Okay, there's one. All right. Two, we're going to analyze probability distributions and see if they're valid. So let's talk about this. Let's recall, what does it take for a probability distribution to be valid? So what would have to be true about these values? They have to do what? They have to add up to 1 or 100%. These are the values expressed as proportions. So the key is, do these, I didn't mean to click that. Do these values add up to 1? And so this first one does. So this could be a valid probability distribution because the probability is summed to 1, because this plus this, all the possible outcomes in the sample space add up to 1. Let's look at the next one. It's the same first two, but a different last one. So I think we see where this is going here. Does that probability distribution add up to 1? No. So this one does not sum up to 1. So this one's not a valid probability distribution. Okay. All right. So now we're going to deal with a couple of discrete probability distributions, and we're going to look at computing the expected value and standard deviation. Expected value is the same thing as the mean. Okay. So it's the same thing as here, the mean. Now, to do the expected value, you can do all this fancy stuff right here if you want to do the expected value. It's each x times each probability, the sum of each x times each probability, or you could use your calculator to do this. Okay, and so I think we might prefer the calculator. So to do this, we'll go to stats, enter. Okay, and I'm going to go to the list. I'm going to press the top of the list. I'm going to press clear. I'm going to press down. And I'm going to enter the outcomes. I'm going to put the x's in L1. I'm going to put the p of x's in L2. So I put my x's in L1, my p of x's in L2. Okay, and so what this will do, our calculator will find the expected value and standard deviation for us. All right. So now what I'm going to do next is I'm going to press stats, hit the right button for calc, and I'm going to go to 1-bar stats. My list is L1, but the key is I have to add a frequency list because these values right here tell me how frequently these outcomes happen. So I have to press second 2 for L2 because I put my frequency list in L2. Okay, calculate. My mean is my X bar. So 0.06 is my mean, or 0.6 is my mean. Sorry about that. And standard deviation round to 4 decimal places. My standard deviation sigma right here. So 0.5831. Okay, so calculator is probably the easier way on that. Now, question number 4 will be on your test, and so there's something on there. We did not talk about that. Uh, and so we're going to talk about here. So what's the income distribution of super shoppers? A supermarket super shopper is defined as a shopper whom at least 70% of the items purchased were on sale with a coupon. The following table income units are in thousands of dollars, and each interval goes up, but does not include the high value. The midpoints are given the nearest $1,000. Okay, so if they have an income range here, 20%, 2% of them are super shoppers, 22% of the super shoppers were in this income range, 20% were in this range. So using the income midpoints, so the income midpoints right here. What are the percent of super shoppers? Do we have a valid probability distribution? To be a valid probability distribution, what has to happen? Yeah, these have to add up to 100%, or if they're decimals, they have to add up to 1. So 22 plus 13 plus 20 plus 16 plus 20 plus 9, they add up to 100%. So now 100% is equivalent to the number 1. So do we have a valid probability distribution? Yes. Now the other thing is these events are distinct. Okay. The events are distinct. What does that mean? Like each one is different. Like each income range is different. So you have to fall into one of those distinct categories. Okay. Now, B, we're going to use SALT here, use a histogram to graph the probability distribution. Now, because the data is summarized into categories, you have to use SALT and create a bar chart. So you could use SALT to do a bar chart. You could also eyeball this, but I'm going to use SALT. So I'm going to use SALT here, and I'm going to do a bar chart. So I'm going to click SALT. Unfortunately, SALT will not do the mean and standard deviation that I'm aware of. I tried to do it earlier, and I can't figure it out. So once you do SALT, you're going to click Charts and Graphs. And then you're going to be on the bar chart, which it already defaults to there, and you're going to select your variable midpoint. And so it does the bar chart there. I'm going to pull this out so you can see. So we've got the first one has a frequency. Let's see if we can scroll up a little bit. The first one has a frequency of 10. So the first one has a frequency of 10. I believe, or no, I'm sorry, of 22. I'm sorry, the 10 has a 22, so 22. So it's that could be that one, could be that one. So you could follow it. It dips down and it goes back up. So it looks like it's going to be this one. You see how this one dips down and goes back up, back down, follows that pattern right there. So it's that one. You also could just match the percentages. You could have matched these with the bars here as well. So you could do either way. But so that's B. Now, C and D, we've got to compute the expected income, so the mean and the standard deviation. Okay, so what I'm going to do is they want you to use your midpoints as X. So I'm going to go to Stat, Enter. Okay, I can clear this, clear down. And I'm going to enter my midpoints as X. 30, 40, 50, 60. And my Y's are going to be these as proportions. You have to do them as decimals, as proportions, okay? So 22% is 0.22, 13% is 0.13, then 0.2, 0.16, 0.2, whoops, and then 0.09. Okay. So those are my proportions there, percents. Then I'll go to Stats, Calc, 1-bar stats. L1's my list. L2 is my frequency list. We need to put there second 2. Calculate, and so my mean is my X bar, which is 32.6. So I don't have 2 decimal places, so I'm just going to do this. And my standard deviation round to 2 decimal places, so 16.47. So 2 decimal places. So my mean's right there, my standard deviation's right there.